Welcome to The Explainer. You know, we hear all the time about forever chemicals, or PFAS, and the health risks they might pose. But when scientists have tried to pin down a specific link to diabetes, the evidence has been, well, messy, super contradictory. Today, we're diving into a paper that claims to have finally figured out why, and its answer could really change how we look at the connection between chemicals and chronic disease. So let's just start with the big question, the one that's been a real head-scratcher for researchers for years. Why is it that when we look at the association between these common forever chemicals and diabetes, the results are all over the map? Seriously, different studies just can't seem to agree. And this isn't some small detail, it's a major scientific puzzle.
Okay, let's really break this puzzle down. To get why this new study is such a big deal, we first have to understand just how confusing the evidence has been up to this point.
Check this out. A major review of studies from 2023 really lays the problem out bare. When scientists follow people over a long time, in what we call cohort studies, they pretty consistently find a link. But in studies that just take a one-time snapshot, the cross-sectional studies, the results are a total mess. Some find a link, some find nothing, and a few even suggest the opposite. And yeah, this is the heart of the problem right here. This inconsistency has been a huge roadblock. It makes it almost impossible for scientists and public health officials to draw any real conclusions. It really begs the question, what on earth is messing with the results of these snapshot studies?
And that brings us to the main idea of the paper we're looking at today. The authors point their finger at one primary suspect for all this confusion, a tricky phenomenon known as reverse causation.
So what in the world is reverse causation? Put simply, it's when the thing you're studying, the outcome, which in this case is having diabetes, actually turns around and influences the thing you're measuring, which is the level of PFAS in the blood. The key idea here is that it's not just about PFAS causing diabetes, but the very fact of having diabetes potentially changing a person's PFAS levels.
This makes a lot more sense when you look at how it might actually happen. See, a diabetes diagnosis often kicks off two big changes. First, people change their lifestyle, their diet, for example, which could totally change how much PFAS they're taking in. And second, there are physiological changes. A big one is something called glomerular hyperfiltration. It's an early stage of kidney trouble in diabetes that can actually make you excrete chemicals like PFS faster. Either one of these things could artificially change a person's PFS levels after they get the disease, completely muddying the data.
All right, so if that's your theory, how do you prove it? Well, to test this whole reverse causation idea and get a clear signal, the researchers needed a really clever study design, one that could basically perform surgery on the data to remove this potential bias.
And their solution was honestly pretty brilliant in its simplicity. Instead of including people who already knew they had diabetes, which is what most studies do, they did the complete opposite. They excluded them. They just took them right out of the analysis. By removing the one group where the disease might be messing with PFS levels, they hope to get a clean, unbiased look at the real relationship. So, here's exactly how they did it. They started with a big group, almost 3,000 adults. First, boom, they took out the 277 people who already had a diabetes diagnosis. That left them with a group to check for undiagnosed diabetes. Then, for their second analysis, where they wanted to look at the even earlier stage of pre-diabetes, they removed those with undiagnosed diabetes too. It's this systematic filtering that created a really clean data set, letting them see the link between PFAS and the very first steps toward the disease, before any diagnosis could mess things up.
Okay, so they did all this work to clean up the data and get rid of that potential bias. Did it pay off? What did they find? Well, it turns out the picture became much, much clearer.
Yeah, the findings were pretty striking. Once they took out the potential for reverse causation, the study found clear, positive links between several PFAS compounds and the risk of having either undiagnosed diabetes or prediabetes. That fuzzy, confusing signal from all the previous research, it suddenly became sharp and clear.
And here's what's really important. It wasn't just about one or two chemicals acting alone. They used this advanced statistical model to look at the effect of the PFAS mixture, which is, how we're all exposed in the real world. And this graph shows a really clear, significant trend. As the total amount of PFAS in the body goes up, so does the risk of prediabetes.
Let's put some hard numbers on that. For one of the compounds, PFHS, people in the highest exposure group had a 1.72 times higher risk of having prediabetes compared to those with the lowest exposure. I mean, that's a 72% increase in risk.
And the result was almost identical for PFAS, which was the most common PFAS they found in people's blood. Again, the highest exposure group had a 1.71 times greater risk.
a 71% increase. These are not small numbers, folks. This is a significant finding.
And this gets to the heart of their conclusion. As the authors themselves put it, it seems that PFAS exposure might be messing with the body's ability to manage blood sugar, our glucose homeostasis, even in that very early pre-diabetic stage. This is all happening long before formal diagnosis and way before reverse causation could ever become a factor.
So you can see, this is a pretty big deal. But what does this breakthrough really mean for the bigger picture, for public health, and for where the research goes from here?
Well, there are three huge takeaways. First, this study is basically a masterclass in how reverse causation can hide the truth in data, and it gives other researchers a roadmap to fix it. Second, it shifts our focus to prediabetes. It identifies PFAS as a potential risk factor during that critical time when we can actually step in and prevent the disease. And finally, it really sets the stage for the kind of long-term studies we need to confirm these findings and prove causality once and for all.
And that leaves us with a really powerful final question to think about. As we're fighting this huge global diabetes epidemic, this research suggests we might need to look beyond the usual suspects of just diet and exercise. Could managing our exposure to environmental chemicals like PFAS be a critical and, up until now, overlooked frontier in preventing diabetes? It's a thought that could really reshape public health for years to come.